Thank you, everybody, for joining us. Please come in, take a seat. I will be passing the mic over to Marko and Sergey. They will be talking about how to ship code faster with AI-powered NoSQL schema design. The floor is yours, gentlemen.
Thank you, and welcome everyone to this session. So I'm Marko, and I have Sergey with me. How many of you are building NoSQL applications using Azure Cosmos DB? Raise your hands. Okay, how about MongoDB? DynamoDB or something else? Okay, great. So anyway, modern developers really love NoSQL databases like Azure Cosmos DB because it's really easy to evolve and iterate on the NoSQL schema using JSON. And obviously, thinking about Azure Cosmos DB specifically, it's optimized for low latency, highly scalable applications. They can be like more traditional applications, but today, oftentimes we talk about AI and agents, and so it's really great for both operational data, vector data, and also for AI native applications. You will be able to store everything in one single place, which is very important. You will be able to keep your embeddings up to date when you have new operational data, so that's super important. There's no data movement. And in Azure Cosmos DB, we have a lot of intelligent features like integrated vector search, full text search, even hybrid search with semantic re-ranking. And also, it has great integrations with tools like Microsoft Foundry, where you can host your large language models, of course, and you've been hearing a lot about Foundry, as well as AI SDKs and so on. And it's really built for these low latency, globally distributed AI workloads. So a great example is, for example, OpenAI, who is using very heavily Azure Cosmos DB for their ChatGPT service. Now, thinking about development and AI, so we all know vibe coding, for example. You're using probably Copilot, GitHub Copilot to build applications faster, and there are also different other tools that you can use to build faster, even faster than with regular NoSQL. But then there are also ways to, for example, use AI to generate queries and code using natural language. MCP integration, super important, is like a USB-C for apps and agents these days, a standard way to connect to databases and other services securely. And now, in this demo session, we are also going to talk about Azure Cosmos DB Agent Kit, and basically, this is where I'm going to hand over to Sergey, who is going to show an amazing demo about how to use that. So, the floor is yours.
Thank you, Marko. Hi, everyone. Nice to meet you all. So, let's take a look at our demo scenario, what we're going to show today. We have very simple, classic e-commerce application data model with customer domain, products domain, and sales order domains. As a starting point, most of the apologies. This looks like I lost connection.
When you reconnected your VM to control up at the top, you could minimize.
Oh, I see it now.
Minimize that one. Now minimize.
Thank you.
There you go.
OK. Go back to my demo scenario. Starting point, we see classic applications where they try to modernize something. They take schema and they modernize table to container. While this approach works and it's OK, it's not optimal approach. And we're going to show you in our demo how to optimize this classic pattern to skip this and take advantage of our knowledge on NoSQL design and best practices to iterate faster. And what we're going to use in our demo is Azure Cosmos DB Agent Kit, which is nothing less than just a set of best practices package in Copilot skills, which you can deploy anywhere. We deploy it in VS Code extension, but you can deploy it in any other Copilot. They all can. As long as your Copilot agent can take advantage of skills, they would be useful. So let's quickly jump in a demo directly. I'm going to minimize this for a second. What we have here is our Cosmos agent kit. This is a public repo. Anybody can download and install it. All it takes is npx skills add Azure Cosmos DB Cosmos agent kit to install it locally. What it does, it deploy agent skills Cosmos DB best practices and a bunch of rules. There is over 100 rules right now. They are indexed, so when you ask Copilot do something with NoSQL Cosmos DB, depending on what you're doing, whether you're evaluating a model or you building a code, based on best practices, depending on the code SDK, it applies a certain set of skills to optimize it. We're going to show you what it does in our case. And then from our demo perspective, I kind of package everything in a repo, which you can take away and follow. But the first thing I did from scenario perspective, I added the knowledge domain to scenario because in NoSQL, it's very important to optimize not just for data model, but for access patterns. And while I have the data model kind of like taken from like tables, relationships, I want to document what my access patterns are in a structured context so the agent can understand and take advantage of this. So I defined 4 access patterns. 1, get customer and their 5 most recent orders with relative volume. 2nd, get one order with line items. 3rd one is CRUD operation, place new order. And the 4th one is list all from products domain, list all products in a category sorted by price, ascending. And then there is some extended order patterns for post-launch, pattern 2. Second part is volumetrics. A lot of times we see developers when they start, they often, they don't potentially know how much data they're going to have, but it's important to think about it from projection. What is the order of magnitude difference would be? And what we do to simplify this, because you don't know what you don't know, but you want to start somewhere. So we define what we see in a demo, but for AI, Copilot, we also document what is our production target. So for demo, we only test with 10 customers. Like you're not going to test with million in development. But in production, we expect to be 10 million, so whatever the number would be. And then you do it for all the entities you have, and that would give you the range for analysis to actually project. Whatever works for 10, will it work for 10 million? And that's very important, especially in NoSQL distributed database, because every mistake you do early actually going to penalize you later. So those 2 things are important as a context to add in the iterations. Now let's look into actual iterations. So the first thing is, if we take that naive design, manual anti-pattern A, I would call, where each container, each table become a container, we can pick a partition key, we can run it. I pre-ran it so we don't have to spend a whole lot of time. This is the example of the naive iteration where I create a simple API to run all those access patterns. I documented the request units, which is Cosmos DB virtual compute charge to actually run per request. You can see that some of those are somewhat high, even for small data set. Now, I also want to show you second often seen anti-pattern in NoSQL, where because NoSQL gives you flexibility to combine things together, a lot of times we see it's taken to extreme. It's taken to extreme where that combination actually creating massive write amplification. To demo this, I'm going to show you where we preceded the container in the emulator with customer with embedded order. So everything is a customer document. and I can embed orders in the order array. So if I'm going to simulate, whenever I create an order, I update the array, I'll show you what happens to a charge to a request. So if I go to 𝗦𝗽𝗲𝗶, let me run this. Oh, it's already seeded. Now you see I'm simulating the updating the arrays, and you see how with the document size grows, the cost of the request also increase. And at the end, I'm actually going to project that with my document, with only 50 iterations, my document grew to 300 kilobytes plus, but also my compute charge to process the document also increased to 130 request units. From initial, where we start on iteration 10, it was like only 60 kilobytes to 26 request units. This is an pattern we see a lot where because NoSQL gives you flexibility to keep updating the arrays, we see like, oh, well, I'm going to just keep patching it without understanding the compute penalty for this. This is an anti-pattern we also recommend to avoid. So if we take those two anti-patterns and say, how can we optimize the data model to avoid those mistakes early and measure the difference in the impact? So we'll go into iteration of, let's take optimized agent-guided design, taking those agent skills, agent kit skills installed early. So I'm going to take, now I'm going to, literally I'm lazy, I'm going to just move all to Copilot prompt, and I'm going to keep adding it. So this is a summary I just ran earlier. It summarizes the naive pattern A request patterns. I'm going to say Copilot, let's take those inputs, take the access patterns and value metrics as a context, and then propose optimal Cosmos NoSQL container design, partition key strategy, indexing, accounting for access patterns and volumes, and write full recommendations in MD file. So now it's reading our access patterns value metrics. It's reading the agent kit skills for Cosmos DB as the best practices, trying to parse what it's done in naive iterations. Checking what was initially set up as a container per table design, and creating a recommendation. And I wish it could done it faster. Let's go.
It seems to be taking some time.
Yeah, it seems to be taking some time, yes.
Yeah. Maybe you can recap like what we've done so far while we are waiting. Oh.
Yes. So what we've done so far is we showed the classic looks like it's, yeah. So it finally came up with a model. Now you see that instead of container per table model, it's actually recommended to collapse domains for customer and orders together and products and categories together customer orders partitioned by customer ID, which give you customer docs plus order docs with type discriminator. And line items would be embedded in order document. And in products, both products and categories are, because they access by category ID and there is not enough requirement to separate them from the access patterns, we can package them up in a category ID and then have product docs, category denormalized. We can actually tell, like this is an iterative loop where if you're not sure why, you can ask Copilot and say, explain why or rationalize it. Or when you have additional requirements, you can feed it in. So just for the sake of order, I would accept this and take this and deploy as a next step. So next step, take this output, create local emulator with partition keys and index policies defined here in the document. This is the beauty of Cosmos DB. While Cosmos DB is a NoSQL database in Azure only cloud, we also have the very nice emulator, which installed locally in my VM and runs locally. And iterating on the emulator is really, really fast and easy. So it should be creating it in a minute. This is pretty much emulator where in the initial database IA1 was customers' orders, product categories, products as individual containers with individual documents. In the emulator, you can pick any document as a point lookup, like basic key value, or you can read it as a query, like select star from container where customer ID equal C0015. And I think it should be, if we refresh, it's probably done. No, not yet. Let me see. OK, it's creating containers now.
It's still running.
All right. I think now it should create and evaluate them. Yeah, now it's creating the next database and containers, customer orders. You can see that it created updated index policy with all the properties we use in the access patterns. OK, I think it's done. We can go to next step. Let's seed and validate data shapes as the next step. So because we combine in the next step, we asking, now that you've created containers and defined index policies and partition keys, take sample data, like in CSV, based on the entities, and convert them into combined document shapes based on the combined entities with type discriminators, and then validate everything from the data type matches and everything. So this will quickly go and create a data migration and data conversion tool to convert the data, load those converted JSON documents into the containers, and validate the shapes and counts. And you can see that it's building the seeding scripts now after analyzing the data. The one thing it's calling out that there is a special decimal parser in the CSV files as an example, and it's taken, as it converts to JSON data, because we don't have in JSON, there's only primitive data types you need to convert properly. Same thing happens with data types in JSON documents in Cosmos DB. We don't have a data type, but we convert all the timestamps and dates in ISO formats as string, which allow us to do proper date ranges, sorts, and everything else with data types. So it ran the script, should be executing it now. Now it's querying to validate, do some sampling. We can actually go here now and see our combined documents. So this is our customer with type customer. Customer ID is a partition key. ID is a unique combination of partition key and ID in Cosmos give you that unique key value identifier, and our embedded order summaries. And then we have also type order with the same partition key with order line items built in. So this is all done. Should be able to go to next step. Now let's build the application code now to test all those access patterns. So I define simple structure, models, repository service, and main, and Python agent kit. And I'm going to just call out, like, use Cosmos DB best practices. And I document at the bottom how I want to summarize the outputs for access patterns for P1 through P4, so I can compare them to the pre-run in the naive model to actually measure the execution of the request units before and after to actually show the difference. Yeah, it's rereading now that we're moving from the data model to actual code development. It's rereading the Cosmos DB best practice skills, but in a different section to actually get the SDK best practice skills. How to do the retries, how to do the client, singleton client, and all other stuff. Looks like it gets confused with my .env because I have example there.
Yeah. I wonder if my, can you guys hear me? Yeah. Oh, I didn't know that you can hear me. How many of you have used Azure Cosmos DB Emulator? Okay. Go and give it a try. The Linux version is now out in GA as of today. So there's been an existing one, but like this is a VNext version. So go and give it a try. Runs on your Mac or Windows laptop, Linux.
Well, it's running. We only have a few minutes left, so what I'm going to do, I'm going to show you the end result of this and just have the pre-run version model. And in the end result of this, maximize it, go back. So this is a summary table of a comparison of iteration A naive versus iteration B optimized. So we took P1, P2, and P3 as strong wins, and we measure delta in the percentage, but also look at the difference of how many are used per request we save in. So in the P1, we save in more than 50% request units per request. In the P2, 75% requests. In P3, 40% requests. There is some differences. P2B is actually shown. It's true in both cases. It's shown the difference between the single document retrieval using the point read versus query. And the P4 is really just a red herring because the difference is like 0.09. So that percentage is just overhead. What's most important thing is when I tell that what would be the monthly cost savings if I combine those are used and project for production workload based on my volumetrics. I'm saving about 3,000 reads per second for P1 and P2, and 500 writes per second for P3. So if I combine those savings and convert them to like list price in Cosmos DB, I'll save about $980,000 per month by optimizing my schema. So this is a true overhead. We see customers losing on the table by not optimizing and doing like lazy conversions. And to me, this is like the biggest value of using NoSQL database, take advantage of full flexibility, but also use API to validate what you do, is it optimal? And like you see probably in many talks, if you think of this as like every time you develop something and build, run the agent kit to validate and use the API to quickly validate and measure the outputs without building complex things to do this. And you can do the same thing with new things. Like whenever you have the new requirements, feed them into the Copilot and say, this is my existing application structure. This is my new requirements. What need to be changed and what need to be fed? All right, we have, I don't even think we have questions, but I'll be happy to step out if anybody has any questions after.
All right. Thank you, everyone.